Thank you, Vicky. I'm very excited to be here and back in Shanghai. My name is Arun Gupta. I'm a principal open source technologist, work in the open source team at Amazon. Amazon EKS is our managed Kubernetes service, and it was launched over a year ago. It is one of the fastest growing service at AWS. In this talk, I will share some lessons for running tens of thousands of production clusters for our customers. Amazon has 14 leadership principles which drives what the company does. And customer obsession is one of the most important ones. Security is job zero at AWS. And then operational performance followed very closely by it. So today I will look at it, Kubernetes from those lenses. As we were operating Amazon EKS cluster, how did we see through customer obsession, security, and operational stability? Everything at Amazon that we do starts with customers. We are not competitor driven, we are customer obsessed. We look at the customer, what they want, and then we start from there and we work backwards from there. Roughly 90 to 95% of our roadmap is driven by what customers want. We talk to customers, we understand their needs, we obsess over it, and then that's how we define what our roadmap is going to look like. And then about 5 to 10% is about the strategic interpretations of what the customers would really want. A classic example of what the customer want from us is, they said, Kubernetes is cool, we love it, but running a Kubernetes cluster is hard. And so we listened to our customers, and that's where we launched Amazon EKS. An example for 5 to 10% is AWS Lambda, which is where we thought that the customers would like this, and we launched that over 4 years ago. Now, managing Kubernetes cluster is hard. When customers told us that this is undifferentiated heavy lifting for them, that's the reason for creating Amazon EKS. So let's take a look at it. As we were talking to our customers in our journey, what were their asks, and how does Amazon EKS kind of map to it, essentially? Now, customers wanted to leverage everything they have learned using Kubernetes, whether it's on their desktop, on-prem, wherever they're running it, they want to bring that expertise, but onto the cloud. And they also want to make sure that this is done in a 100% conformant way, where there are no forks, no branches, everything is done in upstream compatible way. So they know they can use Kubernetes for what it is best for, as a platform for platforms. So Amazon EKS, one of the core tenets is upstream compatible. There are no internal forks or branches at all at Amazon. And it is certified Kubernetes. So what that means is, whatever Kubernetes you are running on your desktop, on your on-prem, in the cloud is all the same version. And that is very important. So what that means is, your existing investment works out of the box with Amazon EKS. As I said, open source contribution is a core tenet for Amazon EKS. Some of the core components of Amazon EKS are out in the open source as well, whether it's the CNI plugin, whether it's the authenticator on how we authenticate a Kubernetes cluster, or is the EKS Army, which is how you create your data nodes or bring your data plane, and all the Packer scripts are available. So some of our partners have created custom armies using those Packer scripts, because this is all out in the open source. We also contribute to a wide range of open source projects, and you can look at some of those. One of the ones that I want to call out specifically is EKS Scuttle, which is done by one of our partners. It's a very easy way to get started with creating an Amazon EKS cluster. Literally, EKS Scuttle, create, cluster, and you got a cluster up and running. Another ask from our customers was, control plane is undifferentiated heavy lifting. I want to run a Kubernetes cluster up in the cloud, but then I don't know what EC2 instances to use. Should my etcd be co-located with the master? Should it be secured? How should it be secured? How it should be backed up? What if my number of pods on my control plane goes high? How do you scale that? How do you patch that? So that's a very common ask from the customer. So our very first need was very evidently clear that all we want to do is provide a managed control plane to begin with. So if you look at Amazon EKS, it's a fully managed, highly available control plane. etcd is secured and backed up. and it scales based upon your traffic. Another key ask from our customers was that as you are taking Kubernetes and deploying it at scale, make sure you test it. It's very important because that's what kind of gives you that conformance feeling, essentially. So we run full set of tests. Now, whether it's end-to-end tests, upgrade tests, we launched GPU support a few months ago, like early last year, and all the performance tests. So we do run high scalability tests as part of each EKS release, so as to make sure that your workloads are very well supported on Amazon EKS. And then the last ask really was that Kubernetes is cool. I love the innovation that is happening in the community. Give me that integration. If I'm an AWS customer, give me that seamless integration with the AWS technologies. But don't make it compulsory for me. So what I've listed over here on the right side is some of the integrations that are available. So things like, if you are running control plane and data plane, then all those logs go to CloudWatch. If you are doing auditing, it goes to CloudTrail. If you're doing authentication, then we are using IAM, which is how you do security on AWS platform. So all of those integrations are available to you out of the box, and there is no heavy lifting that you need to do as part of that. One of the most exciting things for me particularly is the containers team is really going out there. They're really talking about having a transparent roadmap. This works across all container services. So what I'm showing you, I would encourage you to go to this URL and take a look at the transparent roadmap. This particular one is with the EKS filter, essentially. So as you can see on the top right, we have Kubernetes 1.13. The support came out a few days ago. And I'm super excited to announce that Amazon EKS is coming in Ningxia region and the Hong Kong region in the next few weeks. And if you have more feature support, more features that you want to ask for us, I would encourage you to file a bug over here. This is exactly how we are customer obsessed. We listen to customers, we listen to your needs, and that's what defines our roadmap on what are the next set of features that we're going to work on. Now let's switch gears. Let's talk about security a little bit. Security and compliance is a shared responsibility between AWS and the customer. What that means is security of the cloud is AWS responsibility, but security in the cloud is customer responsibility, right? Let's take a look at it a little bit more in detail. Now, the shared model can help relieve customers' operational burden as AWS manages, operates, and controls the infrastructure, the operating system, down to the physical security of the facilities where the data center is running. So you don't have to worry about that. But then customer, which is you, assumes the responsibility and management of the guest operating system, the patching, and everything that comes along as part of that. And we provide a lot of abstracts and application concepts for you so that your data is secured, at rest, in motion, and a lot of different tools that are available for you. Now let's see how this translates from Kubernetes perspective. Now if you think from AWS perspective or Amazon EKS perspective, control plane is fully managed. So the fact that it is highly available, the fact that etcd is secured and backed up, the fact that they are not co-located, that's what gives it high availability as well. Those are all our responsibility. On top of that, what is the army that you want to use for your data plane? Whether you want to use the Amazon Linux 2 default army or you want to bring Ubuntu army, that is totally up to you. Now you can use RBAC policies on top of that, or you want to make your API server endpoint private. That is completely up to you. We provide tools for all of that. What IAM roles you want to use for securing and authenticating your cluster, those are completely your responsibility. So we see in that sense, it's a shared responsibility between you and us, and we would love to work with you on understanding more and more of this. Let's talk about the last aspect of it, which is sort of the operational stability. Okay? Now, Amazon EKS is available in 13 regions around the world, with support for more coming. At Amazon scale, how do we roll out support for Kubernetes to a particular region? Or if we were to patch a particular region for a newer version of Kubernetes, how do we do that? Well, the concept of region is AWS has multiple regions around the world. And this is a physical location around the world where data centers are co-located. Now, each region is distributed across multiple AZs or availability zones, and that gives you the ability to build applications that are resilient. Now, what we do is, for deployment purposes, if you look at it, these are showing 2 regions, and each region has multiple availability zones. Now, for deployment purpose, each region, or rather each availability zone, is split up into multiple cells. And each cell, essentially, the capacity of a cell is defined by the number of clusters that can be created in that cell. Okay? So now when we are doing a deployment, a major deployment of Kubernetes, say a new version or updating a new version, then we deploy to a cell. We run our health checks, make sure the clusters are up and running, make sure all our health checks are passing. If that is successful, then we move on to the next cell, and then next cell, and then next cell, so on and so forth. So that gives us, there are a lot of advantages for that sort of an architecture, and I'll talk about that in a second. But essentially, once one availability zone and all the cells in that availability zone are updated, then we move to the next availability zone, and so on and so forth, and then to the next region. So that kind of gives you the ability to really do a cell-based architecture, essentially. So what are some of the advantages of such a cell-based architecture? Well, the first advantage really is it gives you a lower blast radius. And at Amazon, we always think in terms of blast radius, basically, that if there is a problem happening somewhere, how big the blast radius is, how much of an impact it's going to cause to the customer. Now, breaking up a service into multiple cells helps reduce the blast radius. Because cells essentially represent the bulkhead that provide containment for many common failure scenarios. So if a failure really happens within a cell, it is contained within the cell so that the other cells are not impacted. Now, when properly isolated from each other, this is the way the cells are being done. Cells have the failure commitments similar to regions. So if the cell goes bad, then only the customers in that cell will be impacted. And we always think in terms of how to further reduce the blast radius of a cell. Cell-based architectures scale out rather than scale up and are inherently more scalable. So it gives you a lot more scalability in terms of how many customers can be deployed in a particular region. It also gives you higher testability because the capped size of cells is well understood and tested for maximal behavior, that how much it can scale. So we know exactly how much it can be tested because it's not changing on a regular basis. As I said, the capacity of a cell is defined by the number of clusters that are deployed into it. Another key part of this cell-based architecture is how it gives you a higher MTBF or higher mean time between failures. The probability of an outage is also lower with cells. Now, they have a consistent cap size, so every day is not a new adventure because you know exactly this is my cell size, and you keep testing that again and again. So the mean time between failures is a lot less in that sense. And another advantage is the mean time to repair. Cells are also easier to recover because the number of hosts that you are touching or the operating system that need to be patched for a particular cause is much smaller. And so the repair is a lot quicker as well. And last but not the least, one of the big advantages of cells is higher availability. Now, of course, you have a system with n cells, so possibly n errors, but then 1nth the impact. But the higher MTBF and a lower MTTR really gives us to that better recoverability and overall a higher availability. So these are some of the advantages of a cell-based architecture, and this is exactly how Amazon EKS is deployed when you're rolling out Kubernetes to a region or upgrading to a new version. When we are testing Kubernetes, upstream Kubernetes is cool, but we also need to test Kubernetes in Amazon EKS topology. So some of the points that I'm highlighting here are, for example, in our case, master and HCD are highly available, and they are not co-located because we want to make sure that the master stays independent and HCD is a stateful database so that we can upgrade either one of them independently. Of course, our HCD is secured and backed up. We use authentication using IAM as opposed to the client-side authentication. We also have the cross-account ENI because the control plane is running in the AWS account and the data plane is running in the customer account. So we want to make sure that this cross-account ENI works. We also have a CNI plugin, which basically gives you native AWS networking. So we want to make sure that when we are deploying Kubernetes in that topology, it just works out of the box for the customers. And a wide range of load balancers, pick what you like. So whether it's an ELB, NLB, or an ALB. We also have the ability to say private access for API server endpoint. And last but not the least, we also offer 99.9% SLA. And so I would encourage you to read more about it on our website and what that means to you. So as I said, when we deploy Kubernetes as part of Amazon EKS, those are the three factors that really drives us. So we are really looking forward to listening from you more and more as, what features would you like to us? As I said, Amazon EKS is already coming to Ningxia and Hong Kong. So we're very excited about that in the next few weeks. Security is job zero and operational stability is really, followed very closely by it. One of the things I want to highlight also is, this is a book that one of my colleagues wrote. It talks about open source in the enterprise. This book is translated in Chinese. So I would highly encourage you to come down to the booth and collect your copy of the book. I am part of the open source team as well. Now, we have about 200 plus blogs that we have written, which talks about, how open source works, and all of the customer projects that are using open source at Amazon. All of those blogs are actually translated in Chinese. So I would love for you to subscribe to our blog, read those blogs, and tell us what other content that you would like to see. Once again, my name is Arun Gupta, and I'm going to be hanging out at the conference today. If you have questions, come talk to me, please. Thank you.